Hello everyone, welcome to my channel. So today we will be talking about straight line. Also, to get few basics, I would recommend you to watch my previous video of a line wherein I have explained what is the slope of a line and what is the distance formula. So further moving with the straight line concepts. So what exactly is a straight line? Basically is a line that can be in a any fashion, straight, inclined, vertical, horizontal. Now today we are going to talk about this line. So basically in last video I derived what is the slope of a line. Slope is given by formula y2 minus y1 upon x2 minus x1, which also equals to tan of theta. This description or the proof can be found out in the previous video. So starting with slope of a line. So basically we all know that slope of a line we need to be defined with 2 points. We need to be defined with 2 points. The first point is x1 comma y1, that is the coordinates of point, and the second point would be x2 comma y2. To know what kind of slope is this, that is slope can be either positive or the slope can be negative, slope can be either 0 or slope can also be infinite. Let us discuss about these types of slopes of a line. Let me show it graphically. So suppose this is a x-axis, this is my y-axis. Suppose I am talking about, for example, a line is like this. Here angle is theta. If this angle here, I'll just make an presumption or a trick to remember this. Here, if the angle made with respect to horizontal is acute, I repeat, if the angle made with respect to horizontal or with the x-axis is acute, that is less than 90 degree, then it is having a positive slope. Similarly, if we proceed ahead, if the angle made with respect to horizontal is 90 degree, then here we can quickly relate it in formula. That in formula we can see that although we are having y2 y1, means we know the value of the numerator, but the value of the denominator, that is x1, will be equals to x2. Therefore the denominator becomes equal to 0, and we very well know that any number divided by 0 will give us infinity. Therefore slope of a line parallel to y-axis or the line which makes 90 degree with respect to horizontal x-axis has a slope of infinity. Further moving on with, if now I increase the angle greater than 90 degree. Now if I increase the angle greater than 90 degree, so my angle is still here. So for this particular line whose angle is with respect to horizontal is greater than 90 degree, is having a negative slope. So I repeat, angle of a line with respect to horizontal which makes an acute angle is positive slope, which is having 90 degree angle with respect to horizontal x-axis is having infinite slope, whereas a line which has negative slope as having an obtuse angle with respect to horizontal will be having a negative slope. Now we further move on with the further concepts, like when will be the line have zero slope? The line will be having a zero slope if the line has no angle, that is it lies on the x-axis, or if a line is zero slope, if a line is parallel to x-axis, or we can call it as infinite slope if the line is perpendicular to x-axis or parallel to y-axis. Okay, so now we see what exactly will be the slope of parallel lines and slope of perpendicular line. So if there are two lines like this, so one is this line, the second one is this line. So we can clearly see that these two lines are parallel. That means their inclination angle theta is also same. If both are having same angle theta, then we can say tan theta value for the slope will always be same. That is, both the lines will be having same slope. So here, therefore, so let me take it as line 1 and line 2. So slope of parallel lines, are equal. The line 1 has a slope m1 and line 2 has a slope m2, which can be represented as m1 is equals to m2. Now further imagine that we are having two lines which are perpendicular. We are having two lines which are perpendicular. Let the slope of this line be m1 and the slope of this line be m2, and the angle between the two lines is 90 degree. Here we can say that slope of perpendicular lines are, here there is a relation between the slope of the perpendicular lines. We can say that m1 is equals to minus 1 by m2, wherein we can clearly say that product of the slopes of the perpendicular lines is equals to minus 1. We can say that product of the slope of the perpendicular lines is equals to minus 1, whereas for the parallel lines the slope of the lines are equal. Now we take an example to find slope of a line passing through the given points 2, 5 and minus 4, minus 4. We can see that 2, 5 lies in the first quadrant, whereas the point minus 4, minus 4 lies in the third quadrant. So as per the formula of slope, it is y2 minus y1 upon x2 minus x1. So here we are having, let's represent here itself that this point has a coordinate x1, y1, this point has a coordinate x2, y2. Therefore value of y2 is minus 4, y1 is 5, whereas x2 is minus 4 and x1 is 2. So on simplifying, we have minus 4 minus 5 is minus 9 upon minus 6. Minus minus gets cancelled. This is 3 2s are 6, 3 3s are 9, and we have our answer as 3 by 2. So here we are having the slope of line is equals to 3 by 2. Let this be the sum number 1. So we move on with the second sum, that is sum number 2. Let the sum number 2 be, here we have to find the value of k if the points minus 2, minus 3, k, 4 and 5, 5 are collinear. are collinear. So basically, what do you mean by collinear? Suppose collinear means points will always be in a straight line. So if I take this point 1, point 2, so the slope between point 1 and point 2 will be equal as the slope which is to be found out between point 1 and point 3. So both the lines will be having the same slope since they are overlapping lines, or we can also call it as they are parallel lines. So further we move on to find the slope of the line between this point and this point. So slope, so I name this point as 1, this as second point, this as third point. So point 1, slope between point 1 and point 3 is equals to, so here we can clearly see that this is x2 y2, this is x1 y1. I just represent everything in terms of x1 y1 and x2 y2. So this point is having slope x1 y1, this point is having slope x2 y2, wherein we substitute in the formula y2 minus y1 upon x2 minus x1. So value of y2 would be 5 minus y1 is minus 3 upon x2 is 5 minus x1 is minus 2. On simplifying, we have 5 plus 3 upon 5 plus 2, that is equals to 8 by 7. So here we got the slope of the line between points 1 and point 3, that is 8 by 7. Now we move further. Further we can clearly see that the slope of line 1 3 is equal to slope of line 1 2. Therefore slope of line 1 3 is equals to slope of line 1 2. Therefore slope of line 1 3 is 8 by 7, that is equals to slope of line 1 2 is equals to, so here 1 and 2. So let me name the second point slope as x2, this is y2, and remember that I am going to use slope between point 1 and point 2. So here the formula is again same, y2 minus y1 upon x2 minus x1. Therefore we have 4 minus of minus 3 upon, we have k and minus 2, that is x2 minus x1 is k minus of minus 2, wherein it can be 4 plus 3 upon k plus 2 is 8 upon 7. Now we can simplify this. Therefore 4 plus 3 would be 7. K plus 2. So now we further solve the equation, that is 8 by 7 is equals to 7 upon k plus 2. Therefore we cross multiply, k plus 2 is equals to 7 into 7. So we know that 7 sevens are 49, 8k plus 8 twos are 16. With this we are having 49 minus 16 is equals to 8k. Therefore k is equals to 49 minus 16 by 8. This can be easily be simplified as 49 minus 16 is 33, 33 by 8. Therefore we got the value of k as 33 by 8. And we find the unknown value k from the given 3 points. So in today's lecture we saw what is the slope of a line, we saw what is the slope of a line we saw what is a positive slope, when it is a negative slope, when it is zero slope, and when it is having an infinite slope. So we have seen the concepts, and we have also seen few example how to solve or how to find slope of a line, and how to find the unknown value k when the lines are collinear. So please do like and subscribe my channel, and please stay tuned for more concepts. Thank you.